So, you probably are all very aware that we've got multiple different types of OCPP standards, as well as ISO 15118 standards with both -2 and -20. And increasingly, that becomes a lot more challenging to make sure that all of that kind of seamlessly works together. It really multiplies the amount of variations that we have in our industry as well. Now, even though those are some challenging things, our next speaker is going to really walk through what some of those challenges are more specifically, but also help us find some of the solutions for that. So with that in mind, please put your hands together for Arne Schlowak. He's our lead test engineer over at Hubject.
Thank you. Thank you for coming. Hello again. My name is Arne Schlowak. I'm the lead test engineer at the Hubject testing facility. On a regular basis, we test EVs, chargers, and also CPMS systems. And I want to give some insights in our testing. And today, I would like to focus on the TLS handshake, specifically between EV and EVSE, because with this multi-standard that we are living in right now, namely ISO 15118-20 now is the new addition, there are new added complexities to the TLS handshake. And I would show some examples where we need to be very careful and configure our crypto libraries correctly. So before, one slide for motivation. ISO 15118-20 is coming. I think this is no new information. But what does the R4 Delegated Act has to say about it? So starting from 1st of January 2027, all publicly accessible recharging points built or installed, like I said before 1st of January, need to comply to the 15118-20 and also to the -2 and offer an authentication and authorization method such as plug and charge. So wording is quite clear. The -20 will go quite fast from being the new protocol that enabled some important new use cases to something that is an absolute necessity. So let's have a quick look back at the TLS history in EV charging. Of course, DIN Spec 7121 2012 came along without any TLS, so your traffic between EV and EVSE is unencrypted. Some people might say, okay, authentication is outside of this protocol, so there's no need to encrypt anything. I would argue against it. Your EVSE ID, SCCC ID, requested energies, departure times, all of that are in plain text. And crosstalk is part of this HomePlug GreenFi standard. And so my point is, it's quite easy to sniff this traffic, even if you're not physically connected to the cable. So of course, there's some incentive to hide this information. Of course, then 2014, ISO 15118-2 comes along, and still not really any TLS used, but there's a glimmer of hope. Plug and charge comes along and that mandates for this authentication method, it is mandated to use TLS 1.2 with server-side authentication. Now, fast forward to 2022, TLS 1.3 is mandated and with mutual authentication. That means client-side and server-side need to send certificates to authenticate themselves. So, quick look on the main use cases of -20. I think you've seen a slide like that probably at this conference a couple of times. But anyways, megawatt charging is a big driver. It's mandated, -20. On application layer, it's -20. The cool thing is on physical layer, it will be automotive Ethernet, most likely. So that means no more slack to worry about. I think this is great news. But everybody else still stuck with slack. And another use case for the -20 is the BPT, bidirectional power transfer. I think we're all quite excited about it. And of course, that's a Hubject slide, so I need to also mention plug and charge. Multi-contract is now also enabled by default, so you can install multiple contract certificates in one session. But again, the game-changing detail I want to focus on today is that TLS with mutual authentication is now mandatory. If you do not have the TLS handshake and everything that comes with it under control, you cannot charge. So what that means, also what comes with it, you're sending certificates, so you need to install them, you need to renew them, you need to have all the routes, etc. So let's look at a couple of scenarios where it might become tricky. But first, I want to mention that the -20 will not exist in a vacuum. That means just because we have a new charging standard, it doesn't mean the DIN spec goes away or the -2 goes away. They will still be inside the software stack of the client, of the EV, and in the server. So when we test, we need to have that in mind. Only configuring one side to do one of those will not be enough. It will always be in coexistence. So one tricky scenario. Let's assume you have your multi-stack EV, right? Multi-stack meaning all the protocols implemented with a public Hubject PKI, and you roll up to a multi-stack charger with a private PKI. Is that a very big edge case? I don't think so. You probably heard of Renault and Mobilize. They're doing great work with the AC bidirectional charging, and they're using, for example, private PKI. And of course, in this case, when you have the public and private PKI, the routes are not matching. So the server would send over a certificate and you cannot validate it on client side. Of course, TLS thought of that. It wouldn't be so popular and successful if there wouldn't be a fix. There is a fix. And for that, we need to look at the TLS extensions in the client hello. And for example, for TLS 1.3, and it's also mandated by the -20, you need to implement certificate authorities extension. And for TLS 1.2, respectively the -2, trusted CA keys extension must be implemented. So this is a way of the client telling the server, hey, dear server, I trust these routes. So when you send me a certificate for authentication, make sure it's one of those that I trust. And of course, you guessed it, that's the kicker. Most cars don't implement that, and even if they implement it, the server doesn't change behavior. So this is something we need to watch out for. Another scenario might be your multi-stack EV rolling up to a -2 only charger. You might say, okay, that's the easy one. You just fall back to TLS 1.2 and -2. Of course, there's also an extension, supported versions. That's quite simple to do. One thing to mention here, because I've seen some people go wrong with it, the TLS record layer will still say TLS 1.2, even if you do a TLS 1.3 session, but the extensions in the client hello in the supported version will tell you what version you actually are supported and then what version the server selects. But another thing that we need to watch out here is the key exchange mechanism. The key exchange mechanism changed in TLS 1.2 and 1.3. So how is the symmetric session key that we need for encryption and later on authentication, how is it derived? Before, in TLS 1.2, it was a server key exchange, a dedicated TLS message. And now, in TLS 1.3, it's a key share. And we must be very careful not to mix and match, because also the underlying cryptography in these two standards is different, right? You use different curves, different signature algorithms, so mix and matching will not get you to a symmetric session key that you can work with. Another one, for completeness reasons, but still, I mean, a very important one, is multi-stack EV rolls up to a DIN spec only charger. Okay, that means we need to go back to plain text communication via DIN spec, and that of course means no interesting fun stuff, so no plug and charge authentication. You need to then take this option away, and also no -20 communication. So, but I don't want to leave you like that, just saying what you need to watch out for. I want to be a little bit more helpful and show you how this could look like. I know this is a very busy slide, so let's walk through it together. We have the 4 involved parties in this TLS handshake. We have the EVCC, communication controller on EV side, SCCC, communication controller on charger side, OCPP backend, CPMS, CSMS, many names for it, but basically the server controlling your charger. And then the OCSP responder, happily hosted by Hubject. And of course, we're only looking at the TLS handshake here, right? Plug-in, state change, duty cycle 5%, all omitted, also Slack not shown. But before you actually start the TLS handshake, you now need to get an OCSP status for your certificate chain. What is OCSP again? That is basically saying, in the meantime, this certificate has not been revoked, right? Why is it now even more important? Because -2 tells you TLS server-side certificates are valid for 3 months. Now they are 1 year, so longer, so more time to go wrong, somewhere in between, keys getting compromised or something like that. So this check becomes more important. And I also put a little 3 here, indicating that you need to do that for the entire chain, right? You have the leaf, sub 2, sub 1, so you need to do that 3 times. Also, OCPP has you covered. There's a use case for it. Your charger doesn't need to reach out directly for the OCSP responder. You already have OCPP working, hopefully. So just use the use case and get this status. So then you can cache this OCSP status for up to seven days. That's completely decoupled. It will not mess up the flow of the TLS in any way. You just do that beforehand and then you store it. Then STP request is sent with TLS with security TLS, right? Client saying, I want to do TLS. Server comes back, charger comes back saying, okay, let's do TLS. Here is our IPv6 address and some port numbers we're going to use. After that TCP handshake, I omitted it here. I don't show you anything new when I show you 3-way TCP handshake. Then comes the client hello, where I mentioned that a lot of the complexity is in this message. We need to configure it correctly. And I have a slide prepared in just a second. But the client hello is where the client tells you, I have these ciphers that I support, these curves, these signatures, please choose one. Server comes back, selects whatever it needs, whatever it supports on his side, selects them. You have encrypted extensions. This is also new in TLS 1.3. So everything that is not necessary for the key exchange is already encrypted. So that very little information is leaked. Before then, TLS 1.2, all extensions were in plain text. Then certificate request. I mentioned it before, it's now mutual authentication. So server telling the client, I need a certificate from you. After that, the server actually sends its certificates over, CPO chain, and stapled to it the OCSP status that we got before over here. After that certificate verify message, that's just saying I have the possession of the private key with some signature, then a finished message, like a MAC over the last handshake messages for integrity, and then you could theoretically already start sending application data messages. Of course, now the other side, client comes back with its certificate. And one thing to note here, if you didn't ask for the certificates, this client is not allowed to send them. So there's no graceful handling. If you don't include this message, client cannot give you its certificates. And then, yeah, we have problems. We are not conform anymore. And of course, in BD use cases, right, you want to know who the client is, right? So it is important. So, of course, when you have the certificates, you can again do this OCSP check for the vehicle chain now, right? Before it was the CPO chain, or also called V2G certificate chain in OCPP. Now you get the vehicle chain, you check the vehicle chain, you again do the certificate verify, finish message, and then you can send application data messages. So a lot of going on. And also one thing to note here, that even now the TLS handshake is a function that you cannot really test point to point. You always need to have a CPMS connected and an OCSP responder. So point-to-point testing will not really work. So again, a little bit more going into detail. I hope that will help somebody. Client hello extension. These are not all the extensions, just the ones that I think are important. Of course, supported versions. Again, we need to think. We have multi-stack, right? Everything. The client now needs to support TLS 1.2 and 1.3. You show the versions that you support, 1.3, 1.2. The ciphers, the first one with the Galois counter mode, this is -20. The SHA-SHA-20 is also from the -20, and this one is from the -2. The keen observer will know, okay, but there's a second one, -20. It doesn't provide perfect forward secrecy, so don't use it. It's the one with elliptic curve Diffie-Hellman without the E. In general, just don't use it. Signature algorithm, are shown here. First two ones also from Dash 2. Last with a SECP 256R1. This is from the Dash 20. Again, everything put together, right? Supported groups. Now it becomes tricky. SECP 521. This is what Hubject uses for Dash 20. SECP 256 is what we use in Dash 2. The Edwards curve at the moment not really used. I just put it in parentheses. But you need to show I support those two groups. And now comes one thing I really want to mention is this key share that I already mentioned. This is a TLS 1.3 only extension. So a TLS 1.2 server will not understand that. So since we are now, this is Dash 20 extension only, you need to show only, or I would recommend only to show the Dash 20 curve. And do not include the other curve. Otherwise you mix and match already. I understand that this extension, the server should ignore it if it doesn't understand it. But again, these are the things, you can make it easy for the server if you just don't do it. And even if there's also a hello retry mechanism, so even if something gets messed up, you could potentially send it again. So really no harm in simply only putting the SECP 521 in here. And then trusted CA keys extension, I also mentioned already. You need to show what roots you have installed. In this example, the Hubject root V2G from the prod from Dash 2 and Dash 20. And then one more thing you need to do, still doesn't end, status request needs to be also in the extensions, because this is where you ask for the multi-stapling. Yeah? Include the OCSP status in your certificate message. And just for completeness, for Dash 2, this multi-stapling was also already mandated. But this extension, the status request v2, was deprecated. Nobody really used it. End of the story, more or less, is in Dash 2, nobody did multi-stapling. But now it is mandated, and TLS 1.3 has everything figured out. So, and Dash 20 tells you to do it, so we need to do it. Okay, a little bit advertising. This is our test facility. We have a lot of offers, a lot of services. We do conformance tests, of course, regular stuff. We do this interoperability testing, yeah, just plugging a whole bunch of chargers that OEMs really like that. We also test CPO backends. We do one of our best services is the EVC check, where we prepare chargers to do plug and charge productively. We also do the same for the EV. And of course, we also help you in the field testing. So if you want us to drive out and debug something, we also do that. Okay, a couple key takeaways that I hope I got across is that Dash 20 is coming. 1st of January 2027 is like a deadline. That's not far away. We should start right away. The complexity is rising with TLS 1.3. I hope I could convince you there's some stuff new, and it looks different than the TLS 1.2 handshake that we are used to. And there are interoperability challenges with these two versions now. When you test it, I know all your developers can mock up all the CPMS and OCSP and, with OpenSSL, deploy their own PKI and everything like that. But do you really want them to do that? Just come to us. We provide these puzzle pieces, even in early development, and they don't need to mock everything up. They just come and you get all these pieces for testing, because, again, it's all end-to-end. Another thing that's very close to my heart, personally, is in EV charging, we have a tendency to do a lot of happy pass or good case testing, right? So my charger charged with car A, B, and C with plug and charge, so my plug and charge implementation is good. Of course, completely valid. Please do that, but don't stop there, right? So what happens if the CPMS by accident sends a corrupted route? It shouldn't brick your charger. If the CPMS sends a Dash 20 route, but you're only Dash 2, it shouldn't brick your charger. Stuff like that, like go beyond just good case testing. We offer a comprehensive interoperability testing catalog specifically for that. And how do we come up with these ideas? That's just simply because if a TLS or plug-in charge authentication is not working, the first reaction of most people in the industry is like, send it to Hubject, ask them what's wrong. So this is, and we help at the Sharon Test server, etc., etc. So we have a lot of insights and then derive these test cases from it. Yeah. If you need help, of course, with any of that, you can write us a ticket. So this is synced with our head of. I'm quite proud to do that. So even with no contract at all with Hubject, just go to support.hubject.com, top right side, submit a request, drop down to testing facility. Then it will come to Ivan, Ono, and me. Give us your logs. Don't forget your session key so that we can decrypt your logs. And we will do our best to help you out. I will be annoying and tell you to come test with us, but I will also do my best and try to find the issue. Thank you.
Great. Thank you very much, Ivan. Sorry, Arne. Brilliant. We now have some time for questions as well. Are there any questions from the audience? Whilst we have Arne here.
Hi Arne, this is Rahmi from Vestel.
Hello.
My question is, you mentioned with the TLS 1.3 there will be no point-to-point communication, and I will also relate to the AFIR from this point. And you also mentioned that the AFIR will affect only the public chargers, but there are also rumors it will also affect the private ones. But in this point of view, TLS 1.3 will not be available if a charger doesn't have connection. So, what do you see in point of AFIR? What should this -20 really affect as the hardware level? Which products?
Okay, that's a hard question. I'm really more the technical guys on the policies. I don't know what will come in the future, so that's quite hard for me to say. What I meant with this point-to-point, I just want to mention that you cannot test it. There's always more parties involved, right? So I just wanted to raise attention that there's more to it to the TLS handshake. So of course, if in the private environment you don't need that, so there are less requirements on the TLS handshake, of course, that's fine, then you do it. Again, all of that I just showed here is what the ISO-20 tells you to do. Like Hubject didn't do any of that. We just see it and then we deploy it in that way. If that changes, if requirements are lower in private environment, of course, then you do it easier.
Okay. Thank you.
And maybe just to add, we've also got someone from our team who heads up all the policy and regulation side. So I'll see if I can grab her perhaps after this session and see if we can get you a more specific answer. Yeah, exactly. So we can do that. Any other questions? Maybe just to have a quick check. Okay, now before I let you go, maybe just a quick request from our team as well. There's a stand just a little bit by the door, just on the far right of you over there. And it's basically about trying to make sure that we're all staying really committed to the 2035 CO2 goals as well. So if you haven't seen that already, please make your way over at some point. We would love to have your signature kind of on there, just as a real show of support for that as well. So if you haven't spotted it yet, it's literally just by the smaller door, just on the other side there. But thank you very much. Thanks again, Arne.
Thank you.